Welcome Clarity Coders. If you're sitting there wanting to start some coding today, we're going to show you how to make charts just like these with the live Corona data set. Let's jump right in. The first thing we need to do if we want to start plotting and analyzing real-world data sets is to get our data. So today we're going to be working with the COVID-19 data set that maps out cases by counties. So we're going to grab that from Kaggle. Kaggle is a huge online data science community that has a lot of different databases and contests that you can use for analyzing data and working with different libraries. So we're going to search for the Corona counties. And you can see here that we got a data set that pulls up right away. This is the one that we're going to be using. It's updated. I think it's managed by the New York Times. I will have a copy of this in our GitHub. But if you want to get the latest one, you can browse to this site. I'll post a link below and simply click here to download the CSV. Now, once you have your data set downloaded, it should be in your downloads folder in a zip directory. We're going to just extract this. I'm just going to do it right here in place. And then you should have a CSV of the data here. I'm going to go ahead and click and drag this into a folder on my desktop that I'm going to put all my scripts in. It's very important that this data file is in the same spot as your Python scripts we're going to write here. So now I have that in my folder, and this is going to be where I'm going to save the scripts that we're going to create. Now I'm going to go ahead and open Spider. If you don't have Python installed and you want to program along with us, the easiest way is to install Anaconda. It comes with Spider, which we can write our programs in. And it also comes with the two libraries that we're going to use today, Matplotlib and Pandas. If you don't know how to download it or you want some help with it, I have a video right here that you can click on and watch that. Pause this video and come back with us. So I'm going to assume you have Spider or some type of editor that you like to use. We're going to go ahead and just create a new file. Now, like I said before, it's very important that we put this in the same directory that our data file is in. So I'm going to go ahead and save this file, and we're going to plot a state's data here. So I'm just going to call it plot_state. And we should be good here. Now, usually I would investigate the data set a little bit before I write any code, but just to use the tools we have in front of us for free, I'm going to go ahead and just import the data, and then we can look at it inside of Spider. So the first thing I'm going to do here is import my two libraries that we're going to be using. The first is Matplotlib, and the second is Pandas. You'll see most of the time they're imported in and referenced with these variables, PLT for Matplotlib and PD for Pandas. So we're going to stick with that same syntax here. Now, once we have those imported, we can import our data. So what we're going to do is we're going to use Pandas. So we're going to reference pd.read_csv because that's the type of file that our data was in, and then we can pass the path of our file. Now, assuming you have it in the same directory as the script that we're writing here, we can just reference it with a string, and if we run this, you'll see that it did create us a data frame up here. If you didn't import this correctly or you spelled something wrong, you will get an error similar to this. And that will signify that you need to make sure that the data file and your script are in the same directory. So I'm going to go ahead and assume that you got this imported okay. And we can take a closer look at our variable explorer up here. You'll see that we did in fact create a data frame. Now, I didn't explain this very well, but we created a data frame that we called DF. We could have named this anything, but we just followed standards and kind of stuck with the name that I see a lot in the data science community and created a data frame called DF. Now, if we open this up in Spider and take a peek at the data, you'll see here that it's formatted very similar to an Excel document or something of that nature. So we have our columns in our states. We can also see that we have cases and deaths in the same CSV file. Now we'll notice dependent on date, there could be multiple values for the same state because it's also broken out by county. So my first goal here with this data, just to get kind of a grasp of what it's looking at, is to try and plot a single state's cases of the coronavirus. So that's what I'm going to try here. So I'm going to manipulate this data frame and break it down to a single state. Now you can pick any state. I'm just going to pick my home state of Illinois since that's the most relevant to me. And I'm going to just create a new variable called df_Illinois, and I'm going to set it equal to, and now I'm going to reference my original data frame. So my original data frame was df. And then inside of that data frame, I'm going to tell what I want. So in this case, I want to look at the data frame state column, and I'm going to use this syntax very similar to a list. Inside of the square brackets, I'm going to paste the string that I'd want to grab out. Well, it's kind of like a dictionary almost, like the key value here. And then I'm going to say I want that to equal, and I'm going to use the comparison operator, so two equal signs, and I'm going to say I want it to equal Illinois. Now, if I run this again, you'll notice that I have a new data frame here, df_Illinois, and it has less rows. And if I open this up, you will see clearly here that I've narrowed this down to just the Illinois state here. Awesome. So now one thing I want to do, just to keep this a little more organized, if I look at this data right away, I can see that there is a date column here, but it's not recognized as a date right now. So I want to tell pandas explicitly that this is a date. So I'm going to go ahead and convert that column to a date while I'm at it. So I'm going to do that by referencing my data frame and then the column I want to change. And I'm going to set it equal to, and I'm going to use pandas.toDateTime. And then I can pass in whatever I want to change to a date time. In this case, I want to change the date column. So I'm going to go df_Illinois and the date again. And now you'll see if I run this, I get a scary warning. We'll come back to that. But if I take a look at this, you'll see that it is recognizing it as a date time now. It has the double zeros for the time, which none of these have time, and that's okay, but at least it's recognizing it as a date. Now this warning is warning me that I made a change to a copy of a data frame. So what this is telling me is it's saying, hey, if you meant to change your original data frame, the df variable, you didn't. So if you look back at the original data frame for an Illinois row here, you'll notice that I did not change the date time for that. I didn't change this at all, the original data frame. And that's okay, that's what I meant to do. It's just giving me a simple warning saying, I hope that's what you meant to do. If warnings bother you, you can go ahead and tell pandas that you knew this was a copy, you knew this wasn't going to affect the original data frame, and that'll make your error go away. Awesome, so we're very close now. Now if we look at our data frame, we'll notice the only real issue we have now is our cases are still broken out by county. And that means that on any given day, say the 20th here, you'll notice that there's multiple values for the 20th, and multiple cases for the 20th. We want to sum all those up. We just want it to say Illinois on March 20th had X amount of cases. So we want to sum these up based on a certain date. And we can do that with pandas really easily. So I'm going to go ahead and name this series, and I'll talk about that in just a second. And I'm going to call it series Illinois. We'll just call it sum. And we're going to set it equal to, we're going to look at our data frame again, data frame underscore Illinois. And we're going to run our group by function. Now, what do we want to group it by? They're already all Illinois states. We want to group it down to a single date. So we want every date to be grouped together. And then we want it to take the cases and sum those all up. So again, what we're doing here is we're doing a group by function by the date. So it's going to squish all the dates together. And we're saying that the column we're interested in is cases. And we want to sum up all those cases. So essentially, if there's cases in Cook County and Mercer County and a bunch of other counties, it's going to squish all those together and just give us one summed up value for that date. Now, if we run this, you'll notice I kind of saw something coming here. And this is actually a series. It's no longer a data frame. And if we look at that, we can see that now it has an index column and a cases column. And you'll notice that it has, in fact, summed up all the values for any given date. And you'll also notice that that's very close to what we would see in a line plot now. There's an X and Y axis that we can use to actually plot out our data. So let's not waste any more time. Let's go ahead and plot this. So we're going to use the Matplotlib variable that we created up top for the first time. And we're going to call our PLT function and we're going to do a plot. And then we simply have to pass in our X and Y axis variables. Now in this case, they're both stored in our series. So if we look at our Illinois series down here, you can see we got that. We can run a .index on it, and you'll see it passes us back just the dates. And I can also do a Illinois series for values, and it'll pass back just the values. So we're going to plot those. Inside our plot function, we're going to do series underscore Illinois underscore sum.index. as our x-axis. And then we're going to do the same _Illinois _sum dot values. And that's it. Now we're going to go ahead and below, we're going to show this plot. It will show up in Matplotlib. We're going to do plt.show, just in case you're in something else, some other program. And if we run this, you'll see we get our plot out. Now, most of you probably got, if you're using Anaconda or Matplotlib for the first time in it, you probably got it inside this IPython console, which I don't like because you can't really change the size of your graph. So if you want it to pop out like mine did, you can go to Tools, Preference, IPython console, Graphics, and then switch this to automatic from inline. So you want it to be automatic, click OK, and then do console, restart kernel, and you should have it open up in a separate window. So once you have that changed, you'll notice that we do get a fairly ugly line chart here. Has no title, no axis title, no one knows really what's going on. It does have our dates and it does have our values, and we can tell just based on the news that it does follow a similar trajectory to what we would guess. The ugliness aside with this graph, the first thing that I think when I look at this is it doesn't tell us a lot of information we didn't already expect. Remember, every day we're adding more cases and we're never taking any cases away with how we're currently showing the data. So it is obviously going to continue to go straight up over time. Now, this may be something that interests you, but I would like to change it around a little bit and get the difference from each day. So I want the new cases of every day. So if we look at this series, we can see that on the 24th, we had one case, and on the 25th, we also had one case. The 26th, we also had one case, so there were no new cases on these days. That's what I would like to show. I would like to show and graph the new cases so we can kind of see how many new cases we're getting every day. So I'm going to go ahead and do that by grabbing our series again. This time, this is just a variable name, so you can choose whatever you want. I'm choosing to rename it so we can look at both series. You could just overwrite this previous one, but I'm going to call this difference. So we're going to look at the difference. Now, Pandas has a really easy way of comparing this row to the previous row, and so on and so forth. So it's always going to look at the last value and compare it. We're going to ask Pandas to calculate the difference between the current row and the previous row. So the first one will have NA because there is no previous row to calculate it. After that, this would show 0 because these are the same. Now, as we go on in time and we get to like 11 here, it's going to say there's 4 new cases because it went from 7 to 11. So we can do that pretty easily. We're going to use the series that we had before. We're going to do series _Illinois _sum, and we're going to do .diff. And that's going to give us the difference from the previous row. So if I run this, you'll notice the graph is obviously the same. We haven't changed what we're plotting yet, but I'll open up both of these next to each other. So our sum is on the left and our difference is on the right. And now you'll see that we have one case the first day and we get nan for the first day in our difference. And that's because it can't calculate the difference because there's no day before this. Now, starting here, you'll notice that there's no new days. And that's because there were 1 on both of these days. So 1 minus 1 equals 0 new cases. So on and so forth until we get to the 29th. You'll see the 29th is still 0. And if we go to the 30th, you'll see there was 1 new case. And that's where we jumped up to 1. And this is going to give us a little more interesting of a data set here. Because if we start going down here, try and look at the 21st, say, or look at the 21st here, you can see that the new cases kind of jump around, and that's going to give us some dips in our graph. So on the 22nd, for example, we had 296 cases, and then on the 23rd, we actually had less new cases that day. And then right back up to a little higher case percentage there. So this is going to give us a little more interesting graph. So let's go ahead and graph that instead. So remember, here we're still graphing the sum version. Let's change this and graph the difference version. So I'm just going to swap out that variable and point at this variable above. Now, if I run this again, you'll notice still not a pretty chart per se, but it is at least a little more interesting. So now when I look at a graph like this, I can start to think about bigger picture things that I could look to correlate with the data, different things like that. So if we're looking at this data set, can we correlate one of these peaks and valleys with maybe a new policy being put in place, or social distancing, or whatever we're looking at. But we can kind of start deriving some thoughts about the chart in general. Now I'm going to quickly paste in a couple more lines to add some value to this chart. I won't make you watch me type them all out. We can add an X label, which is date, a Y label, which is our new cases, and then a title, which is Illinois new cases per day. And if I run this, you'll see that I get some new nice little titles around here as well. Now we can style this, but we're going to skip that for now. We're not going to stick with this chart for very long. And I wouldn't even show the date. We know that's a date, so I'm going to take that off. And this is kind of where we're going to leave this chart. Now, you said we threw away all the other data. We have just Illinois. You might not care about Illinois, or you might want to look at a different state, or we might want to plot multiple states to our chart. So now that we have this set up and we know how we did it in this case, I want to go ahead and create a chart that has more states on it. So I want to say plot every state. So that's what we're going to do on our next graph. So I'm going to create a new Python script here, and I'm going to save this as all states. I don't think we're going to end up being able to plot all states. It might be a little busy, but we will call it that for now. And the best part about programming, we can grab some of our other columns, right? We can grab all this is going to stay the same. So we're going to import our data just the same. We are actually going to want to do a lot of this the same as well too, right? We're going to want to grab individual states and plot individual states. The only difference being we want multiple states. We don't want just Illinois, we want multiple states. So we can stick with this same kind of setup here. This will give us a place to start. So now, looking at our data, I want a way to grab all the states. You'll notice here, I have to input that I want to graph Illinois, so I pass in a string called Illinois. Well, I want a data frame that I can store all my states in. That way, we can use a for loop to iterate over it and plot every single state. So one thing that I'm going to add here is a variable I'm going to call unique states. And I'm going to set that equal to my original data frame, and I'm going to look at the state column, and I want it to grab me out unique values in that column. And now if I run this, oops, you'll notice it still is plotting our chart. We're not too worried about that right now, but you'll notice I do have a unique states variable now. You'll also notice that in Spider, you can't open this up. It is a NumPy array, but you'll notice it's a little weird. It has 55 items, which kind of throws a little red flag. We're not sure why there's 55 states, but if you open this up, you'll notice that there's some territories in here, so that's why we're getting those 55 states. You'll notice Virgin Islands and Puerto Rico and different things like that. So we do have all of our unique values now. Now in this array, we can iterate over it just like we would any other iterable object, like a list or a dictionary. So I'm going to write a simple for loop here, and I'm going to say for state. Now remember, when I'm using a for loop, that first item is a variable name here. I could call it pizza or whatever I wanted. I'm going to name it something that makes sense to me. So I'm going to call it state in, and then whatever I want to iterate over. So I want to iterate over unique underscore states. Now I want to do everything I did here inside of that for loop. So I'm going to tab it all inside of our for loop. Shrink this over so we can see everything. And now instead of grabbing Illinois here, I want to use whatever value was stored in state. So as this iterates over our list, I can show you here. If I just print out that state each time, this is going to give me the chart pop up again, but you'll notice here it iterated over this and it printed out the state name each time. This is simply a string. So we can use this in place of our hard-coded Illinois here. So I'm going to take that out. And instead, I'm going to use our state variable here. And just for my sanity here, I'm going to change this. We don't really have to, but it's not the Illinois data frame anymore. It is a state data frame. So I'm going to change that and this. And it's not an Illinois series anymore. It's now a state series. And all that was just to keep the naming convention straight. Nothing too serious there. And one other thing, when we plot these out, we want to be able to tell them apart. So let's go ahead and add a label here, and we'll call that label whatever was in the state variable. So it should label it North Dakota, Wyoming, or whatever state we're currently plotting. Let's go ahead and add our legend to the chart as well, so we can see which state we're plotting. And let's go ahead and show our plot. Now if I run this again, wow, that is a pretty cool chart here. Post that to Reddit, they'll torch me. So you can see here that we plotted all the states like we thought we would, and it is not a very useful chart. Our biggest issue right away, even though you can tell one state's out of control, you can't even tell which state it is because there's like 4 different oranges in our legend over here. So we definitely need to limit our chart in some way. Now, my immediate thought when I was looking at this chart is to take the states with the 10 most cases and only show those. That way we can kind of limit what we're showing on our chart. So luckily that's fairly easy to do. If you look at our original data set, I'm gonna find whatever the last date in here is. Now, if you've grabbed an updated version, it might be a different date, which is why we're gonna code it this way. So I'm not gonna hard code in, I wanna grab the 9th. I'm gonna hard code in whatever the oldest date is, grab that date, and then find out what the top 10 states were on that date for cases. I'm not gonna do new cases, I'm just gonna do cases in general. So after I grab my unique states, I'm gonna figure out what the last date was in this data set. So I'm gonna set last date equal to df. I'm gonna look at my date column, and I'm gonna grab the max value in that column. So if I run this, you'll see that I do have a last date now. And if I scroll over, it is what we expected, 2020-04-09. So it's the last date there. So we got our last date. So now I want to grab a data frame with just the last date, only the data that comes with that last date. So I'm going to call it df underscore last underscore date here. I'm going to set it equal to df is the data frame I want to grab it out of, remember? And now what do I want out of this original data frame? I want to grab anything where the date is equal to our last underscore date that we grabbed. So now we should have a data frame with just the values on that last date. And now let's create a series on that last date. And let's sum up the different values for each state to see which one has the most. So I'm going to grab my df underscore last underscore date. I'm going to do a group by again. This time though, I want to look and group it by states because we have all the states in this data frame. And I want to take the cases and I want to sum them up. Now notice we're not doing difference here. You could, and that's something you guys can change this to if you'd like. I'm just doing the top 10 states with the most cases. So I'm going to grab all those values and sum them up. And if I run this, this created a new series for us called series last date. And you'll see it has the sum of all the cases in all the states. Now we could write a for loop and kind of grab out the largest 10 states, but luckily Pandas has this already built in for us in an easy fashion. So we're just going to take the series last date and overwrite that variable. And the series object has a nice function called nLargest on it. And we're just going to grab out the 10 largest states. So now you'll notice we've changed the series last date to be just the top 10 states, the top 10 cases. And now we can iterate over this instead of all of our unique states. So instead of iterating over all the unique states, let's go ahead and just iterate over our series underscore last underscore date dot index, because remember the states were the index. And now if we run this again, you'll see that we've just plotted out our 10 top states and our graph is just a little bit easier here. And that's it. That's how you can work with data and kind of plot it out. Now you can build on this graph and change it as much as you want and format along the way. And I've done a quick little example of that for you guys that I will post on GitHub as well. I am not the most artistic or making things beautiful. You guys will probably have way better ones that you post and share with me than what I do here, but I'll show you a chart that I formatted. Here's a version that I just formatted a little bit. I will post this on the GitHub link as well. If I run this, you'll see I made it just a little bit bigger. I added some labels, changed around the styles a little bit. I formatted the date on the axis and added a few more just to add a little more detail to our chart. Now, all these functions are really easy to use and really easy to manipulate, so you can look up exactly how to format all your lines and everything like that. You can change based on color. You can change the colors of the lines, the styles, all that kind of stuff. One thing I did want to mention here in this video, just so you can see really quick here, this line here on line 11, you can actually import styles to kind of use as a base for your charts. That's kind of how I start them out to at least see what's going on here. And you'll notice that I actually did a print out of all the available styles on this line. This gives you a quick way to kind of try out some different looks and see what your chart you want to start with, and then you can kind of change it from there. You'll notice if you change that string variable out with one of the others, you'll get some different colors and different formatting. Now, obviously, you can make these all exactly what you want, down to adding your own hexadecimal values. So this should get you started playing around with some big data. Let me know what you think. If you like this video and want to see more, please subscribe, like the video. If you need any help with the fundamentals, we do have a course that kind of breaks down everything in detail, exactly how for loops run, everything from setting variables to variable reference. Check that out as well if you're interested. I'll post a link on here. And until next time, keep coding.